Hi dear student, welcome to my channel Education Shop. In this video solve problem 3.35 from the book Heat and Mass from the A.Çengel 6th edition. Here is the statement of the problem. The wall of a refrigerator is constructed of fiberglass insulations. Its thermal conductivity is 0.035 watt per meter Kelvin, sandwiched between two layers of 1 millimeter thick sheet metals. This is the two layers, layer 1 and layer 2. In between, the insulation layer is sandwiched, whose thermal conductivity is 0.035 watt per meter Kelvin, and thermal conductivity of this 1 millimeter sheet is 15.1 watt per meter Kelvin. The refrigerated space is maintained at 3 centigrade. This is the refrigerated space. This is the outside kitchen space, and its temperature is 25 centigrade. And the average heat transfer coefficient at the inner and the outer surface of the valve are 4 watt per meter square Kelvin and 9 watt per meter square Kelvin respectively. The kitchen temperatures average is 25 centigrade. It is observed that condensations occur on the outer surface of the refrigerator when the temperature of the outer surface drops to 20 centigrade. Determine the minimum thickness of the fiberglass insulation that needs to be used in the valve in order to avoid condensation on the outer surface. We need to calculate this thickness of the insulation in order to avoid the condensation at the outer surface of the valve. Outer surface temperature is T1, that is given, that is 20 centigrade, and the kitchen temperature is 25 centigrade. So when the heat is transferred from higher temperature to its lower temperatures, the temperature from higher temperature towards the lower temperatures, the temperature drop from 25 centigrade to 20 centigrade at the outer surface of the sheet metal. Let me write the data that is given in this statement. This is let's say the first layer, this is the second layer, this is the third layer that offer resistance to the heat transfers when the heat transfers takes place from 25 centigrade towards the 3 centigrade. These different layers 1, 2, 3 offer resistance to the heat transfer. Also resistance to the heat transfers offered by outside these sheet metals, and inside this refrigerated space. Now let me write the data that is given in this statement. The thermal conductivity of the insulation is 0.035 watt per meter Kelvin. The thickness of the first sheet and second sheet is x1 is equal to x3, that is 1 millimeter, or in other words 1 multiplied 10 to the power minus 3 meter. The inside temperature is 3 centigrade and the outside temperature is 25 centigrade. The inner convection heat transfer coefficient is 4 watt per meter. And the outside is 9 watt per meter square dot Kelvin. And what is our requirement? In order to avoid condensations at the outer surface of the sheet, we need to find the thickness of the insulations, that is x2 is equal to L. That is our requirement. Consider the area is a unit area, that is 1 meter square. Come toward its solution. Remember, when the heat is transferred from this point till the outer surface of this sheet metal, it will face resistance, the heat transfer Ri. Then this first layer offer resistance to the heat transfer is R1. Then this second layer of the insulation offer resistance R2, and this third layer of the sheet, and this third layer, that is the second sheet, offer resistance R3. And then finally, from this inner surface to the temperatures to the point where the temperature drops to 3 centigrade, it's offer resistance R0, Ri because it's the inside the refrigerated space and it is outside the refrigerated space. The resistance must be R0. The temperature here is T infinity naught, that is 25 centigrade, and the temperature here is T infinity I, that is 3 centigrade. The temperature T1 value is also given at the surface of this outer sheet metal. This is T1 and its value is 20 centigrade. Now the amount of convection heat transfer is equal to H0 A into change in temperature. H0 is 9, area is 1, change in temperature is outside temperature minus T1, that is equal to 9 multiply 1 into 25 minus 20. Simply multiply and you will get the amount of heat transfer till the outer surface of the sheet metals when its temperature is 20 centigrade, that is 45 watt. So this, but we need to calculate the thickness of the insulations in order to avoid condensation at the outer sheet metals. Then we can say that the heat transfer is equal to change in temperatures, and the change in temperatures in between of T infinity naught minus T infinity 1, T infinity I divided by the first resistance, the total resistance in between these two temperatures, that is R0, Ri, R2, R3, Ri. This is R0 plus Ri plus R2 plus R3 plus Ri is equal to Q, and the value of Q we have calculated, that is 45. Inside temperature, the outside temperature is 25 centigrade minus inside temperature is 3 centigrade. The value of R0 is 1 divided by H0 A0 plus the value of R1, that is equal to X1 divided by K1, and A0 is the same for all, that is 1. Here you can see. Then R2 is X2 divided by K2A plus R3, that is X3 divided by K3A plus Ri, that is 1 divided by Hi multiply area. Now just simply enters the values at each corresponding points. Amount of heat transfer is 45 and change in temperature is 22. The H0 value is 9. Take the value of A0 A is 1 meter square plus X1 value is 1 millimeter. Here you can see the value of X1 and X3 is the same, that is 1 millimeter into say 1 multiply 10 to the power minus 3 divided by thermal conductivity, and the thermal conductivity of K1 and K3 is 15.1 plus X2 is the requirement to find, that is L, the thickness of the insulation. K2 value is 0.035 plus X3 again, X3 is 1 millimeter, 1 multiply 10 to the power minus 3 divide K3, that is 15.1, and A area is 1 plus 1 divided by inside convection heat transfer coefficient, that is 4, and area is 1. Now just simply solve this on calculators for this L value and you will get its value. Let me solve this whole equation for the value of L, that is the thickness of the insulation. If you see this value and this value is the same and it repeated twice, that's why I can say that 2 multiply 1 multiply 10 to the power minus 3. This value for this L, we will write X on the display. There's this alpha button, then there's this to show X on the screen, it is 0.035. Now press this shift button, calc, solve for X, yes, and it will give you the thickness of the insulation, that is 4.46 multiplied 10 to the power minus 3. Let me write this on notebook. This 10 to the power minus 3 is basically equal to milli, and we can say that thickness of the insulation is 4.46 millimeter. This is the final required thickness of the insulation in order to avoid condensation at the outer surface of the sheet. Thank you so much.